Hello everybody, welcome to my channel. Today I am going to discuss about one important rearrangement reaction which is present in organic chemistry. So that is called benzyl-benzilic acid rearrangement. So now first thing comes, what is the definition of this particular rearrangement? So here you can see that when 1,2-diketone, which is also called as alpha diketone, rearranged to give the salt of a alpha hydroxy acid in the presence of a base, then this reaction is known as benzyl-benzilic acid rearrangement. So now to understand this rearrangement, first we have to take one important organic compound that is called benzene. So this is the structure of benzene. You can see here it contains two keto group and two phenyl groups. So now it is also called as 1,2-diketone, right? So the special name of this compound is called benzene. Now once you take benzene and try to add the potassium hydroxide as a base under water ethanol solvent medium, and if you try to heat it, so it will give you that potassium benzylate molecule. So now this is the overall reaction of benzyl-benzilic acid rearrangement. Now next thing comes, what is the mechanism of this particular reaction? So in this particular reaction, you can see that this particular reactions basically involves three important steps: step 1, step 2 and step 3. So now let us discuss the step 1. So in the step 1, you can see that there is a fast reversible nucleophilic attack at a carbonyl carbon by the hydroxide ion to form the intermediate 1 compound. So here you can see OH minus is the nucleophile. So that nucleophile, it will attack in this particular carbonyl carbon center, and this carbon oxygen bond open up. So this particular reaction it is very fast reaction, as well as the reaction is basically associated with the equilibrium with the intermediate 1 and the reactant. So now when OH minus attack in this carbon, you can see it will generate a tetrahedral intermediate. Now coming to the step 2. So in step 2, what will happen? So in the step 2, you can see that whatever the intermediate product it was formed in the step 1, so there you can see that there is a 1,2 nucleophilic shift of the phenyl group takes place. 1,2 nucleophilic shift of the phenyl group takes place here. So here you can see that O minus, it will come back. So this phenyl group, it will again attack over there, this carbonyl carbon, and another carbon oxygen bond open up. So as the process is slow, so that's why it is called the rate determining step of this particular reaction. So now after 1,2 nucleophilic shift of the phenyl group, so it will give another intermediate. You may consider it is intermediate 2, right? So here you can see what is the driving force for this 1,2 nucleophilic shift of the phenyl group. So the reason is the driving force for the phenyl migration may be either the pushing of the phenyl group by the negatively charged oxygen atom, or it may be the pulling of the phenyl group by the partially positive carbonyl carbon. So that is why that phenyl migration takes place in this particular step. So next, coming to the final step. So in the final step, that is the third step, what will happen? You can see that there is a rapid proton transfer takes place from a stable carboxylate group. It is the carboxylate group, right? To stable carboxylate group to in this particular O minus. So then you can see it will become OH, and that carboxylate anion, it becomes C double bond O minus and K plus. So that is the overall reaction of benzyl-benzilic acid rearrangement. Now let us discuss couple of organic transformation. You can see if you take benzyl and instead of adding let's say potassium hydroxide, if you try to add potassium tertiary butoxide in presence of tertiary butanol, what will happen? So it will give you this kind of product, you can see. So now in the next reaction, here you can see, so this is the molecule, here you can see that it contains also 1,2-diketone. So there if you add potassium hydroxide under ethanol solvent followed by acidic workup, so it will give you this kind of product. And in the next reaction, you can see, if you take this big molecule, so this is the molecule, you can see, add sodium hydroxide water under heating condition, so it will give you this product. So in the last reaction, here you can see, if you take a substituted that orthomethoxyphenyl group, so there if you add OH minus water, again it will give you this kind of product. So thank you very much for watching.